We'll be back in chemistry next week. Oh, hold on. There is another question. I'll read this one out. Could unexplained early universe supermassive black holes be black holes that began to form in time before the inflation period?
Yes, so this goes back to what we would call primordial black holes, which are ones that formed extremely early on. So yes, in principle, there are a few limits on why we think that might not be the only thing that happened. So the first issue, and this is something people are already just starting to think about, is if you, like I said, black holes and galaxies sort of control each other's growth. Now, if you imagine you end up in a situation where you have a 10 to the 10 solar mass black hole or 10 to the 9 solar mass black hole already in place before there are any stars or before there's any sort of galaxy, it's very hard to imagine how the galaxy would form around it. Because every time you have some cold gas, this extremely massive black hole would get turned on and inject vast amounts of energy and immediately turn off any sort of star formation. So really what we've learned from the simulations is that if it's quite a closely coupled process. It works well if they're sort of in relation, like on the plot I showed you. But if something, if something has a really overmassive black hole, it tends to very quickly turn off any star formation, any evolution in the host galaxy. So what you'd end up with in that scenario is a lot of naked supermassive black holes rather than what we see, which is massive black holes in active galaxies. Right, or in galaxies that have stars and are actively growing. So I think that would be one sort of issue with this. So I think the other thing sort of goes back to this kind of question about, could dark matter be black holes of various masses? If this happens, we'd end up with a lot of black holes that maybe weren't in galaxies, because the kind of theories that looked at this, there's a certain density for them to be forming. It's to do with the structure of the power spectrum early in the universe. You need certain overdensities to form certain black hole masses and such. It'd be very hard to imagine a scenario where this is an efficient process and you only get the really supermassive ones and you don't get a whole spectrum. So we'd be expecting a lot of black holes across the mass range. Again, we don't really see that. And we also don't see, we see the supermassive black holes in the centers of galaxies, but we don't see, I think there's no evidence for lots and lots of them everywhere, if that makes sense. So again, that sort of puts constraints on how they can form, and then you kind of have to come up with a scenario where certain amount of supermassive black holes that form in the early universe, galaxies form around most of them, and they happen to exactly match the distribution we see from the cosmic web structure and such. So it's possible, but it brings its own problems. It's not straightforward to say, well, the galaxies, the black holes are just in place already and everything else forms around it, because the black holes then change how everything else evolves.